Food preservation can be defined as the process of treating and handling food in such a way as to stop or greatly slow down spoilage and prevent foodborne illness while maintaining natural value, texture, and flavor. Classification of food preservation methods: physical methods, chemical methods, and fermentation. Physical methods include preservation by low temperatures, refrigeration and freezing; preservation by high temperature, pasteurization, sterilization and canning; and preservation by drying, sun drying, drying by mechanical dryers, and preservation by irradiation. Chemical methods of food preservation include high concentration of salt, high concentration of sugar, and using chemical preservatives. And the last method is fermentation. So, refrigeration. The temperature maintained in the refrigerator is 0 to 5 degrees Celsius. Enzymatic and microbial changes in foods are slowed down considerably. Perishable foods like eggs, dairy products, meat, seafoods, fruits and vegetables are stored in refrigerators. Food can be stored safely for a few days or a week. Refrigeration cannot improve the quality of decayed food, as it can only retard microbial deterioration. One problem of modern mechanical refrigeration, that of dehydration of foods due to moisture condensation, has been overcome through humidity control mechanisms within the storage chamber and by appropriate packaging techniques. Freezing is one of the easiest, least time consuming and most convenient methods of food preservation. The temperature of freezing is minus 18 to minus 40 degrees Celsius. Microbial growth is prevented completely, and the action of food enzymes greatly reduced. Freezing is very good at retaining the nutritional value and their natural color, flavor, and texture, better than when other methods of food preservation are used. For example, for fruits, meats, breads, cakes, etc. The freezing of food involves lowering its temperature below 0 degrees Celsius, resulting in the gradual conversion of water present in the food into ice. In general, freezing does not destroy spoilage or contamination microorganisms, but it stops their growth as long as the food is kept at minus 18 degrees Celsius. However, some microorganisms, especially molds, are able to reproduce even at very low temperatures. For example, psychrophiles are a group of organisms with the ability to grow and reproduce under low temperatures ranging from minus 20 degrees Celsius to 10 degrees Celsius. This is because the psychrophile cells produce antifreeze protein that permits the cells to stay alive below freezing point. And you should remember that any microorganism present will become active as the food thaws. There are two types of freezing: quick freezing and slow freezing. The faster food freezes, the smaller the crystals that form. Small crystals do less damage to cell walls. So when thawing, cell wall intact. And slow freezing produces large ice crystals that punch through cell membranes. Cell wall has been ruptured when thawing. Also, when foods with large ice crystals thaw, there is more dripping and loss of liquid. Quality of frozen foods. Improper freezing or storage of foods may result in detrimental quality changes. When foods with high amounts of water are frozen slowly, they may experience a loss of fluid called drip upon thawing. This fluid loss causes dehydration and nutrient loss in frozen food products. During frozen storage, the ice crystals present in foods may enlarge in size, producing undesirable changes in texture. This phenomenon is commonly observed when the storage temperature is allowed to fluctuate. For example, ice cream stored in an automatic defrosting domestic freezer becomes sandy in texture because the ice crystals increase in size as the temperature of the system fluctuates. Improperly packaged frozen foods lose small amounts of moisture during storage, resulting in surface dehydration, commonly called freezer burn. Frozen meats with freezer burn have the appearance of brown paper and quickly become rancid. Freezer burn can be minimized by the use of tightly wrapped packages and the elimination of fluctuating temperatures during storage. In this picture you can see vacuum sealing your meat can slow down the process of freezer burn. Now let's discuss high temperature methods. Heat is one of the oldest methods of destroying microorganisms and their spores in food processing and preservation. Development of several high temperature based methods like boiling, roasting, baking and other heat treatments are the greatest advance in food hygiene, because such methods kills all the forms of microorganisms, vegetative and spore, and make the food safe. Pasteurization. It is named after its inventor, French chemist Louis Pasteur. Pasteurization is a selective or gentle heating technique originally developed by Louis Pasteur for milk and milk products. Nowadays, pasteurization is also used for preservation of other beverages like fruit juice, water, etc. Practically, pasteurization involves heating the food to a specific temperature for a definite time and then cooling quickly. Pasteurization is a selective heating technique and it kills some, but not all, microorganisms present in milk. If milk is contaminated by some disease causing microorganisms, milk cannot be heated at boiling temperature to kill these microorganisms. It is because heating at high temperature brings several undesirable changes in milk. It kills beneficial lactic acid bacteria present in milk also. Similarly, casein protein precipitate lactose caramelized flavor of milk changes. Such milk becomes unsuitable for production of milk products like ice cream, cheese. In milk, caseins exist at the calcium salt arranged in cellular particles surrounded by soluble casein. The casein component of milk is relatively heat stable, capable of surviving pasteurization at 62 to 71 degrees Celsius. Conversely, the whey protein component is denaturated at these temperatures. Similar beverages like fruit juice cannot be heated at high temperature because it brings several undesirable changes in flavor, taste, etc. In pasteurization, milk and beverages are heated at lower temperature that kills the spoilage or pathogenic organisms without bringing undesirable changes in the product. There are three techniques of pasteurization of milk which differ in their time-temperature relationship. Time-temperature relation of pasteurization are selected on the basis of three bacteria which are transmitted through milk: Mycobacterium bovis, Brucella abortus, and Coxiella bureti. So these techniques of pasteurization are low temperature holding or wet pasteurization, high temperature short time pasteurization, and ultra pasteurization. Low temperature or wet pasteurization, in this method milk is heating at 62.8 degrees Celsius for 30 minutes, or milk or other beverages. High temperature short time, in this method milk is heated at 71.7 degrees Celsius for only 15 seconds. And ultra pasteurization, milk or other beverages are heated at about 137.8 degrees Celsius for 2 seconds. Also, There are some other types of pasteurization. They also differ of their temperature and holding time. Also, there is ultra pasteurization, ultra high temperature sterilization. On this picture you can see these three types: vat pasteurization, high temperature, short time, but it has become one of the most common methods of pasteurization today, and ultra pasteurization also there is. Vat pasteurization use. Vat pasteurization is used primarily in the dairy industry as a means of preparing milk in the processing of cheese, yogurt, and other common food products. The table below shows the required time and temperature for vat pasteurization of various food products. Ultra-high temperature pasteurization involves heating the milk or beverages or cream to 138 or 150 degrees Celsius for 1 or 2 seconds using commercially sterile equipment and filling it under aseptic conditions into hermetically sealed packaging. The product is termed shelf-stable and may be stored without refrigeration for months until opened. Disadvantages of ultra-high treatment milk taste. First, taste different. High temperature denaturates the immunologically active protein in milk, and the nutritional loss of protein in ultra-high treatment. Pasteurization milk is more than that of pasteurization. Also, the soluble calcium in milk will become insoluble calcium that is difficult to be absorbed by the body after high temperature sterilization. Also, now you can see the difference between pasteurization of milk. In the shops you can see a milk of traditional pasteurization, milk of ultra-high temperature pasteurization, and ultra-high temperature pasteurization plus aseptic packaging, ultra-high temperature. So, traditional, the high temperature short time, it can be stored in fridge for 2 or 3 weeks shelf life. Ultra-high pasteurization, heated in more temperature for less time, and it can be stored for 1 to 2 months. And if we tell about ultra-high pasteurization plus aseptic packaging, so it can be stored without fridging until opened for 6 months. Aseptic process involves placing a sterilized product into a sterilized package that is then sealed under sterile conditions. Blanching is process to salt foods in hot water, and the process consists of three stages: preheating, blanching, and cooling. Blanching is usually considered a preheat treatment before drying, freezing, or canning. It's a process of washing vegetables or fruits in warm water before storage. Advantages of blanching includes that it inactivates enzyme of food that cause self-decomposition. It reduces number of microorganisms present on the surface of food. It brings wilting of leafy vegetables and helps in packaging. And it enhances fixing of intense green color of fruits and vegetables. Effect on foods. Blanching causes cell death and physical and metabolic changes within food cells. Heat damages cytoplasmic and other membranes, which become permeable and result in loss of cell turgor. Water and solids pass into and out of cells, resulting in nutrient losses. Heat also disrupts subcellular organelles, and their constituents become free to interact within the cell. Over-blanching can cause excessive softening and loss of flavor in the food, but the heat treatment is less severe than, for example, in heat sterilization, and the resulting changes in food quality are less pronounced. Canning is the process in which the foods are heated in hermetically sealed, airtight jars or cans to a temperature that destroys microorganisms and inactivates enzymes that can cause food spoilage. The general steps to be adopted for canning foods are cleaning, blanching, filling, exhausting, sealing, sterilizing, cooling, and labeling. Steps for canning foods. Cleaning. It is the first step in canning. Thorough cleaning of the product to be canned helps to remove most of the spoilage organisms. Second step is blanching. This process serves as an additional hot water wash. It inactivates the food enzymes and fixes the natural color of the product. It also softens the fibrous plant tissues and facilitates removal of skin. In this process, the raw food material is immersed in hot water or exposed to leaf stream for 2 to 5 minutes and immediately dipped into cold water to prevent further exposure to heat. Filling. Either manually or by using machinery, the contents can be filled in the cans. A headspace of 6 to 9 mm depth above the level of food in the can must be left. Exhausting. Gases are expelled by passing the open can containing the food through an exhaust box in which hot water or steam is used. It expands the food and expels air and other gases from contents and also from the headspace area of the can. Next step is sealing. The exhausted containers are immediately sealed to avoid recontamination. Sterilization. To bring about complete sterilization, thermal process carried out. This ensures the destruction of spoilage microorganisms. This is usually done by the application of steam under pressure. Cooling. The containers are cooled rapidly to check the action of heat and prevent unnecessary softening of the food or change in the color of the contents. It can be done by means of air or water. Labeling. The containers are labeled with nutritional characteristics of the food inside. Controlling water activity. Foods containing high concentrations of water are generally more susceptible to deterioration by microbial contamination and enzymatic activity. The water content of foods can be controlled by removing water through dehydration or by adding solids to the food. In both cases, the concentration of solids in the food increases and the concentration of water decreases. Next method is drying and dehydration of food materials. What is dehydration? Definition is the removal of water by evaporation from a solid or liquid food with the purpose of obtaining a solid product sufficiently low in water content. In drying or dehydration, water is removed from the food by hot air or heated surface dryers. Examples of the former include cabinet tunnel, conveyor, the fluidized bed dryers, and the later include drum and vacuum shelf dryers. How drying preserves food? Drying removes the moisture from the food so that bacteria, yeast, and mold cannot grow and spoil the food. It also slows down the action of enzymes but does not inactivate them. When the food is ready for use, the water is added back and the food returns to its original shape. Foods can be dried in the sun, in an oven, or in a food dehydration by using the right combination of warm temperatures, low humidity, and air current. The optimum temperature for drying food is 140 Fahrenheit. If high temperatures are used, the food will cook instead of drying. When the food cooks on the outside and the moisture cannot escape, case hardening can occur. The food will eventually mold. Thus, the drying process should never be hurried by raising the drying temperature. Low humidity aids the drying process. Food contains a lot of water. To dry food, the water must move from the food to the surrounding air. If the surrounding air is humid, then drying will be slowed down. Increasing the air current speeds up drying by moving the surrounding moist air away from the food. To speed the drying time, increase the airflow. Most foods can be dried indoors using modern food dehydrators, countertop convection ovens, and conventional ovens. Microwave ovens are recommended only for drying herbs because there is no way to create enough airflow to dry denser foods. Sublimation definition. Sublimation is the transition from the solid phase to the gas phase without passing through an intermediate liquid phase. Freeze drying or lyophilization is the sublimation removal of water content from frozen food. In freeze drying, moisture sublimes directly from the solid state to vapor, thus producing a product with controllable moisture that has no need for cooking or refrigeration and retains its natural flavor and color. Freeze-dried food lasts longer than other preserved food and is very light, which makes it perfect for space travel. Since the water is removed from the product in a frozen state, cell structure remains intact and the finished product appears less shriveled. Freeze drying requires the use of a special machine called a freeze dryer, which has a large chamber for freezing and vacuum pump. Main steps are freezing, vacuum, heat, and condensation. Freezing that the product is frozen. This provides a necessary condition for low temperature drying. Then, next step is vacuum. After freezing, the product is placed under vacuum. This enables the frozen solvent in the product to vaporize without passing through the liquid phase, a process known as sublimation. Heat is applied to the frozen product to accelerate sublimation. And condensation, low temperature condenser plates remove the vaporized solvent from the vacuum chamber by converting it back to a solid. This completes the separation process. Freeze-dried coffee is the best known freeze-dried product. Next type is preservation of food by radiation. There are two types of radiation. They include non-ionizing radiation and ionizing radiation, or called sterilization. First is the non-ionizing radiation. Ultraviolet light is an example of non-ionizing radiation. When microbial cells are exposed to ultraviolet light, it is absorbed by neutrons based on DNA. After absorption, ultraviolet light catalyzes the formation of thymine dimer by linking ring of added thymine. When such DNA replicates, rate of error of replication is very high in the position of thymine dimer. Therefore, ultraviolet light kills the microbial cell by inducing mutation. One major limitation of ultraviolet light in food preservation is its lower penetration power. Therefore, it cannot penetrate into inner layer of solid food and viscous liquid food. So it is applicable only for clear liquid food like clear fruit juice. It can also be used to kill microorganisms on surface of solid food. Application. The ultraviolet light is used to kill microorganisms present in clear liquid foods. For example, it is used to kill yeast cells and other microorganisms in fruit juice. It is used to inhibit growth of yeast and mold on surface of some foods like vinegar, cheese, pickles. Ultraviolet light is commonly used to prevent surface spoilage or various foods including pickles, vinegar. Ultraviolet light is used to disinfect water used for production of beverages. It is used to kill microorganisms present in air or food processing room. It is also used to kill microorganisms on various food processing instruments like knife, eating utensils. And ionizing radiation, X-ray radiation. When microbial cells are exposed to ionizing radiation, they cause ionizing of cytoplasmic water and generate very toxic compounds. They are powerful oxidizing agents and kill the microbial cell by oxidizing various cellular materials. Application. Some applications of ionizing radiation in food preservation includes low level of ionizing radiation is used to kill microorganisms on fresh fruits and vegetables. It is used to kill insects as well as microorganisms on vegetables and fruits. High level of ionizing radiation is used to kill microorganisms and insects on dry vegetables and fruits. Ionizing radiation are commonly used to preserve meat and meat products. For example, irradiation is commonly used to inhibit microorganisms, nematodes, and other parasites present in meat and meat products. In meat, it increases pH damage, glutathione, increase carbonyl compound, and generate bad smelling compound. In fatty food, it damages natural antioxidant and increases change of oxidative rancidity. It causes loss of several vitamins like thiamine, vitamin C, D, A, B12. Therefore, it reduces nutritional value of food. Next up is chemical preservation of food, high concentration of salt, sugar, and chemical preservations. Now let's start from high concentration of salt. It is an ancient preservation technique. Food is treated with salt or strong salt solution. Salt causes high osmotic pressure and shrinking of cell, dehydrates foods and microbes by drawing out moisture. Here you can see process of osmosis. Compare normal cell and cell that contain too little salt and cell that contain too much salt. Salt preserves food. Salt draws water out of cells via the process of osmosis. Essentially, water moves across a cell membrane to try to equalize the salinity or concentration of salt on both sides of the membrane. If you add enough salt, too much water will be removed from a cell for it to stay alive or reproduce. A high concentration of salt kills organisms that decay food and cause disease. A concentration of 20% salt will kill bacteria. Lower concentrations inhibit microbial growth until you get down to the salinity of the cells, which may have the opposite and undesirable effect of providing ideal growing conditions. Pickling. It is also an ancient preservation technique. The preservation of fruits and vegetables using common salt, vinegar, oil, and spices are referred to as pickling. The layer of oil that floats on the top of pickles prevents the entry and growth of microorganisms like mold and yeast. Spices like turmeric, pepper, chili powder retard the growth of bacteria. Vinegar provides an unfavorable acidic environment for microbial growth. The salt added absorbs water and prevents the growth of microorganisms. High concentration of sugar. Sugar has the ability to bind water and make it unavailable for microbial growth. It reduces the solubility of oxygen in moisture, which is essential for the growth and multiplication of microorganisms. Apples, oranges, grapes, pineapples are suitable for making jams. The fruits should be just ripe because the pectin content is high in such fruits. Chemical agents. Different types of chemical preservatives are used to preserve variety of food. But not all food preservative can be used to preserve all types of foods. It's because some chemical preservatives bring some undesirable changes. For example, they can change taste, smell in some food. For example, spices are usually not considered suitable for preservation of milk and milk product because taste of spice in milk product is not considered desirable. So, chemical preservatives are utilized in food preservation in various ways. Some food preservatives are directly mixed with the food to be preserved. Some chemical preservatives are used in a wrapper or container of food rather than in food itself. Some chemical preservatives are placed in area of storage environment of food. Some chemical preservatives are used for treatment or equipment used in food process. Some chemical food preservatives are organic acids, examples propionic acid and propionate, benzoic acid and benzoate, sorbic acid and sorbates, acetic acid and acetates, nitrites and nitrates, smoking, spices and other condiments, and sometimes antibiotics. But using of antibiotics in food preservation is not permitted due to risk of development of antibiotic-resistant microorganisms. Fermentation. Fermentation is one of the age-old methods of food preservation techniques. Fermentation extends the shelf life of the food similar to that of salting and drying. The term fermentation refers to both the anaerobic and aerobic breakdowns of carbohydrates and carbohydrate-like materials. Fermentation means the process of the reaction between microorganisms and organic compounds in natural conditions. Apart from carbohydrate, microorganisms and enzymes react on protein and fat by releasing carbon dioxide and other gases. Fermentation needs anaerobic condition or aerobic. In anaerobic condition, in cheese production, due to Streptococcus lactis bacteria, lactose is converted to lactic acid under anaerobic condition. Aerobic condition, in vinegar production, due to Acetobacter bacteria, ethyl alcohol is oxidized to acetic acid in aerobic condition. Foods produced by fermentation. It can be alcoholic beverages or vinegar preparation. In the presence of oxygen, Acetobacter bacteria convert alcohol to acetic ion. Cheese production. Streptococcus lactis bacteria changes milk sugar into lactic acid. That acid crosses milk into cheese. Citric acid production. Citric acid is produced from yeast, mold, and bacteria. It is used in the production of fruit beverages. Uses of fermentation. Fermentation extends the shelf life of foods. It enhances the growth of microorganisms producing acid and alcohol. It prevents the growth of lipolytic and proteolytic microorganisms. Vinegar obtained by fermentation has industrial importance.